Catatumbo Lightning, the world's most persistent lightning storm. Among the many natural wonders of Earth, few are as mysterious, visually striking, and scientifically fascinating as Catatumbo Lightning. Occurring in a specific region of northwestern Venezuela, this phenomenon is famous for producing lightning almost every night of the year, often for hours at a time, without the constant presence of thunder. Because of its extraordinary frequency and reliability, Catatumbo Lightning has earned several names, including the Lighthouse of the Caribbean and the Everlasting Storm. For centuries, sailors, indigenous communities, scientists, and travelers have observed this remarkable display. In modern times, satellites have confirmed that Catatumbo Lightning is the most lightning-active place on Earth. Beyond its beauty, the phenomenon plays an important role in local ecosystems, atmospheric chemistry, and climate studies. It has also become a powerful cultural symbol for the people of Venezuela. This essay explores Catatumbo Lightning in detail, including its geographic setting, physical causes, scientific significance, historical importance, cultural meaning, and the challenges it faces in a changing climate. Geographic location and setting. Catatumbo Lightning occurs in the Catatumbo River Basin near Lake Maracaibo in northwestern Venezuela. This region lies close to the border with Colombia and is surrounded by dramatic geographic features that play a crucial role in creating the phenomenon. Lake Maracaibo is one of the largest lakes in South America and is connected to the Caribbean Sea by a narrow channel. Warm waters dominate the lake throughout the year, producing high levels of evaporation. Surrounding the lake are several mountain ranges: the Andes Mountains to the south and southwest, the Sierra de Perijá to the west, the Venezuelan coastal range to the north. These mountain barriers form a natural bowl that traps warm, moist air above the lake and river delta. At night, cooler air flows down from the mountains and collides with the warm, humid air rising from the lake. This collision creates powerful atmospheric instability, one of the key ingredients for thunderstorm formation. The storms typically form over the southwestern portion of Lake Maracaibo, especially near the mouth of the Catatumbo River, where wetlands, swamps, and rainforests further increase humidity. What is Catatumbo Lightning? Catatumbo lightning refers to near-continuous lightning activity that occurs in this region on an exceptional scale. Unlike ordinary thunderstorms, which may last only an hour or two, Catatumbo storms can last up to 10 hours in a single night and occur over 200 nights per year. Key characteristics include extremely high lightning frequency, sometimes exceeding 250 lightning flashes per square kilometer per year. Mostly cloud-to-cloud lightning, which illuminates the sky without constant thunder. Regular nightly occurrence, especially during the rainy season. Long-lasting storm systems, rather than brief storm cells. Because the lightning often flashes within the clouds, observers may see constant pulses of light rather than distinct bolts striking the ground. This gives the sky a glowing, strobe-like appearance, visible from hundreds of kilometers away. 1. Warm lake waters. Lake Maracaibo remains warm year-round, typically above 28 degrees Celsius, 82 degrees Fahrenheit. Warm water increases evaporation, which adds large amounts of moisture to the air. Moist air is essential for cloud formation and storm development. 2. Mountain-driven air circulation. At night, cooler, denser air flows down from the surrounding mountains and collides with the warm, moist air above the lake. This creates strong updrafts, forcing air upward into the atmosphere, where it cools and condenses into towering storm clouds. 3. Atmospheric instability. The region often experiences sharp temperature differences between surface air and upper atmospheric layers. This instability allows air parcels to rise rapidly, strengthening thunderstorms and increasing lightning production. 4. Wind patterns. Seasonal wind patterns, including trade winds from the Caribbean, help sustain storm systems by continuously supplying moisture and energy. 5. Methane hypothesis. Debated. Some researchers have suggested that methane gas released from nearby wetlands and oil fields may enhance lightning activity by influencing atmospheric conductivity. While interesting, this hypothesis remains debated and is not considered the primary cause. Lightning formation, a brief scientific explanation. To understand why Catatumbo lightning is so intense, it helps to understand how lightning forms in general. Inside a thundercloud, strong updrafts and downdrafts cause ice particles, hail, and water droplets to collide. These collisions separate electrical charges. Positive charges accumulate near the top of the cloud. Negative charges gather near the bottom. When the electrical difference becomes strong enough, it discharges as lightning. In Catatumbo storms, constant air movement keeps this process going for hours. Because most lightning here occurs within the clouds, thunder may be faint or absent at a distance, making the phenomenon even more unusual. Seasonal patterns. Although Catatumbo lightning can occur year-round, it shows clear seasonal variations. Peak activity, April to November, rainy season. Lower activity, December to March, dry season. During peak months, storms may occur almost every night. During the dry season, lightning frequency decreases, but rarely disappears completely. This consistency has made Catatumbo lightning one of the most predictable natural phenomena on Earth. Historical accounts and early observations. Catatumbo lightning has been observed for centuries, long before modern science attempted to explain it. Colonial and maritime history. During the Spanish colonial era, sailors navigating the Caribbean used the lightning as a natural beacon. Because it was visible from far out at sea, it helped guide ships toward the entrance of Lake Maracaibo, earning the nickname Lighthouse of the Caribbean. One famous historical reference links Catatumbo lightning to a naval battle during the Venezuelan War of Independence. According to legend, the lightning illuminated Spanish ships at night, exposing them to attack. While historians debate the accuracy of this story, it highlights the phenomenon's cultural significance. Cultural significance in Venezuela. Catatumbo lightning holds a special place in Venezuelan identity, especially in the state of Zulia. Symbolism. It appears in regional folklore, poetry, and music. It symbolizes resilience, continuity, and natural power. It is often seen as a guardian of the land. Flag and emblems. The lightning is sometimes represented in regional flags, artwork, and official symbols, reflecting local pride. Oral traditions. Stories passed down through generations describe the lightning as a living presence, an eternal watchman over the lake and its people. Scientific importance. Catatumbo lightning is not just visually impressive, it is also scientifically valuable. Lightning research. Because of its predictability, scientists can study lightning formation, storm dynamics, and electrical processes more easily than in less reliable storm systems. Atmospheric chemistry. Lightning produces nitrogen oxides, which contribute to the formation of ozone in the upper atmosphere. Some researchers estimate that Catatumbo lightning plays a measurable role in regional atmospheric chemistry. Climate studies. Studying how Catatumbo lightning responds to changes in temperature, rainfall, and wind patterns can help scientists understand how thunderstorms may behave under future climate conditions. Satellite discoveries and global recognition. In the late 20th and early 21st centuries, satellites revolutionized the study of Catatumbo Lightning. Satellite data confirmed that the Lake Maracaibo region has the highest lightning density on Earth. This led to international recognition and increased scientific interest. In 2014, Catatumbo Lightning was officially acknowledged by global meteorological organizations as a unique atmospheric phenomenon, further cementing its place in world records. Nutrient cycling benefits plant growth. Atmospheric nitrogen contributes to soil fertility. Animals in the region have adapted to frequent storms, adjusting behaviors such as feeding and nesting to avoid peak lightning hours. Climate change and recent variations. In recent decades, researchers have observed changes in Catatumbo lightning activity. Periods of decline. During severe droughts linked to climate patterns such as El Niño, lightning frequency has temporarily decreased. One notable decline occurred in the early 2000s, raising concerns about long-term changes. Possible causes? Reduced rainfall, changes in wind circulation, altered lake temperatures. While the lightning always returned, these interruptions suggest that Catatumbo lightning is sensitive to broader climate shifts. Conservation and environmental concerns. The Catatumbo region faces environmental challenges that could affect the phenomenon. Deforestation, wetland degradation, pollution from oil extraction, climate variability. Protecting the lake, surrounding forests, and river systems is not only important for biodiversity, but also for preserving the conditions that allow Catatumbo lightning to exist. Tourism and education. Catatumbo lightning has become a growing attraction for ecotourism and scientific tourism. Visitors travel to observe the storms from safe distances, often guided by local experts. When managed responsibly, tourism can support local economies, promote environmental awareness, encourage conservation efforts. Educational programs also use the phenomenon to teach students about meteorology, physics, and climate science. Catatumbo lightning in the global context. While other regions experience frequent lightning, such as parts of Central Africa and Southeast Asia, none match the consistency and duration of Catatumbo lightning. What makes it unique is not just how often lightning occurs, but how predictable and localized it is. This makes it one of the most extraordinary examples of how geography and atmosphere interact. Beyond its beauty, Catatumbo lightning is scientifically important, culturally meaningful, and ecologically significant. It teaches us how delicate balances in nature can create extraordinary results, and how changes to those balances can threaten even the most enduring wonders.